Let's say we have the absolute value of x is less than 5. How do we solve an inequality that has an absolute value? First, let's do this algebraically, and then we'll look logically to see why that makes sense. The first step would be to isolate the absolute value. In this case, we're not multiplying or dividing the absolute value by anything, nor are we adding or subtracting. If that were the case, we would move that over to the other side. After that, we're going to rewrite this inequality without the absolute values, and that's going to require two inequalities. The first one is identical to the original problem, just without the absolute values. In other words, x is going to be less than 5. For the second one, we need to flip the direction of the inequality and make the entire other side a negative. Therefore, x is greater than negative 5. Let's graph this on the number line. I'm going to plot negative 5, positive 5, as well as 0. If x is less than 5, then we're starting at the 5 and shading to the left. X is also greater than negative 5, so we're going to shade to the right from negative 5. Neither has or equal to, so they're going to be open circles. And there's our final result. In interval notation, that would look like parentheses negative 5, comma 5, close parentheses. Now, if you notice, the answers converged in the middle. And that's because if we look at this logically, the absolute value just means the distance from 0. So in this case, we're saying that the distance that x is from 0 must be less than 5. So every point from 0 to negative 5, not including that number, is less than 5 from 0. And the same is true between 0 and positive 5. In that case, we're going to say that this is an AND statement as opposed to an OR statement. When the original problem, after isolating the absolute value, has a greater than sign, then we'll be using an OR, and you'll see that they will be going opposite directions of each other. One more way to write this answer is by saying that negative 5 is less than x, which is less than 5. And reading it from the point of view of the x, that's just saying that x is less than 5, and it's also greater than negative 5. Let's try a similar example, but this time the absolute value of x is going to be greater than 5. First, we can see that the absolute value is already isolated, so we can start writing our two separate inequalities without the absolute values. Again, the first one looks exactly like the original problem. X is greater than 5. The second half, remember, we're going to switch the direction of the inequality and make the other side negative. So x is less than negative 5. On the number line, we have 5 and negative 5. This time, x is greater than 5, open circle and shade to the right. While on the other side, x is less than negative 5, so we're shading to the left. Unlike the previous example, these do not converge. In this case, it's going to be an OR statement, not AND, because x cannot be both less than a negative 5 and also greater than a positive 5. With interval notation, we're going from negative infinity up to negative 5, union, and then we continue from positive 5 up to infinity. Let's try this example. The absolute value of 3x is greater than or equal to 12. The first thing to look out for is whether or not the absolute value is isolated, and it is. So we can jump into writing our two inequalities without the absolute values. The first one is identical. 3x is greater than or equal to 12. And the second one will have 3x, remember, flip the direction, is less than or equal to negative 12. Now we just need to solve for x as if it was a normal equation. In this case, we'll divide both sides by 3. And on the left side, we have x is greater than or equal to 4. We'll do the same on the right side, divide by 3. And over here, x is less than or equal to negative 4. We'll put this on the number line. We know that x is greater than or equal to 4, so we're shading to the right of 4. And because of the or equal to, it needs to be a closed circle. On the other side, x is less than or equal to negative 4, so a closed circle. And we'll shade to the left. Clearly, we can see that these do not converge towards each other. So like we saw before, this will be an OR statement. Using interval notation, we're going from negative infinity to negative 4. But we're including the negative 4, so we'll use a bracket. Union, and we're continuing with positive 4, including the 4. So we'll need a bracket 4, comma, infinity. Let's try a more complicated example. Say we have 2 times the absolute value of 3x minus 4 plus 5 is greater than 25. Clearly, the absolute value is not isolated. We're multiplying by 2 and adding a 5, so we need to move all of that over first. The first step would be to subtract 5 from both sides of the inequality. That leaves us with 2 times the absolute value of 3x minus 4 is now greater than 20. And now we need to divide both sides by 2. And we're left with the absolute value of 3x minus 4 is greater than 10. At this point, we can write our two separate inequalities. First, we have 3x minus 4 is greater than 10. And our second half, 3x minus 4 is switch the direction, less than, and change this side to a negative, negative 10. Now we need to solve just like a normal equation. We'll add 4 to both sides. 3x is greater than 14. Divide by 3. X is greater than 14 thirds. Over here, same thing. We'll add 4 to both sides. 3x is less than negative 6. We'll divide by 3. X is less than negative 2. We know this should be an OR statement because after we isolated the absolute value, we still had a greater than sign. So let's plot this on the number line to prove that's true. We'll put 14 thirds over here and negative 2 to the left. X is greater than 14 thirds. We'll need an open circle and shade to the right. X is less than negative 2. Open circle and shade to the left. With interval notation, we're going from negative infinity up to negative 2, not including the negative 2, so we'll need parentheses. Union, and we pick back up at 14 thirds. We'll use parentheses since we're not including it, comma, infinity. Now what if we have negative 3 times the absolute value of x plus 4/5 is greater than negative 12? As always, first we need to isolate the absolute value, and we can do this by dividing both sides by negative 3. On the left side, we have the absolute value of x plus 4/5. On the right side, we have 4. However, when you have inequalities and you multiply or divide by a negative number, the direction is going to switch. So this becomes a less than symbol. And that's why it's important to isolate the absolute value, because what looked like a greater than, which would be an or statement, is now a less than, which will become an and statement. Now we can write our two inequalities. First, x plus 4/5 is less than 4, and x plus 4/5 is going to be greater than negative 4. Before solving, I'd prefer to get rid of the fractions, and we can do this by multiplying, in this case, both sides of the inequality by 5. So now we have 5x plus 4 is less than 20, and we'll do the same to the side, multiply both sides by 5, and we get 5x plus 4 is greater than negative 20. We just need to solve for x. We'll subtract 4 from both sides, and I'll do it over here at the same time. 5x is now less than 16, and over here, 5x is greater than negative 24. We'll divide both sides by 5. Finally, x is less than 16/5, and x is greater than negative 24/5. We'll graph this on the number line. Negative 24/5 over here, 16/5 to the right. X is less than 16/5, not or equal to, so we need an open circle, and we're going to the left. And x is greater than negative 24/5, also open circle, and we're shading to the right. In interval notation, we're going from negative 24/5 up to 16/5. Let's try this example. Overall, it looks pretty simplistic, but there's something very easy to overlook, which I want you to be careful about anytime you see a problem like this. So notice on the right side, we have more than a monomial like we had before. We have a binomial. We have two parts. The absolute value is already isolated, so we don't have to do anything here, which means we can start writing our two separate inequalities. The first one will be like the original. 2x is less than 3 plus x. On the other side, we know to switch the direction of the inequality, so we're going to have 2x is greater than. However, when we talk about changing the other side to a negative, what that means is we need to apply the negative to the entire other side. So I'm going to put everything on this side in parentheses with the negative in front, just like this. Let's solve the left side first. Here we just need to isolate the x on one side and the numbers on the other. First, we'll subtract x from both sides. We now have x is less than 3. On the right side, let's go ahead and multiply the negative inside and distribute. So we have 2x is greater than negative 3 minus x. We'll add x to both sides. And now we have 3x is greater than negative 3. Divide both sides by 3. And finally, x is greater than negative 1. We'll graph this on the number line. Negative 1 and 3. X is less than 3. Open circle to the left. And x was greater than negative 1. Open circle to the right. With interval notation, we're going from negative 1 up to 3 with parentheses. And we can write it as negative 1 is less than x, which is less than 3. Here's another very important example to know. Say we have the absolute value of 4x plus 3 is greater than negative 2. If you haven't noticed something about this specific inequality, that's okay. We're going to solve this algebraically, and then I'll show you how to recognize how to solve this type of inequality instantly. We'll rewrite our two inequalities. 4x plus 3 is greater than negative 2. On the other side, 4x plus 3 is less than positive 2. We'll first subtract 3 from both sides. 4x is greater than negative 5. Over here, 4x is less than negative 1. We'll divide both sides by 4. Now we have x is greater than negative 5/4. Or, again, because we have greater than, x is less than negative 1/4. Now, if we graph this on the number line, we should notice something here. X is greater than negative 5/4, so open circle, and we're shading to the right. Or x is less than negative 1/4, open circle, shade to the left. But because it's or, there's nothing suggesting that we're going to stop at either number. So when x is greater than negative 5/4, we're actually going to go through and past the negative 1/4, which means it includes that number. And the same is true with x is less than negative 1/4. We're starting from negative 1/4 and going to the left past the negative 5/4. So in reality, our answer is all real numbers, and using interval notation, we're going from negative infinity up to infinity. Now remember, if this was an and statement, that x had to be greater than this smaller number here to the left, and also less than the number here to the right, then we would have only shaded between the respective numbers and could not go past each one. But because we have an or statement, either is okay, so we're going from negative 5/4 past negative 1/4, encompassing all numbers, including negative 1/4, and vice versa, going to the left. Now remember, I said there was a way to solve this instantaneously without doing all of that math. So if you notice, the absolute value here is set to greater than a negative number. And what do we know about the absolute value? That's the distance away from 0. That can never be negative. So the lowest value coming out of this absolute value could only be 0. It can never be negative, because if you end up with a negative in the absolute value, it becomes the positive number. Therefore, anything coming out of this absolute value is always going to be greater than any negative number. Now this time, what if we had the reverse? The absolute value of 4x plus 3 is less than negative 2. Just like before, we can solve this algebraically, but the danger there is that you can actually get a solution that looks real, but in reality, it is not the correct solution. Let's do this algebraically and see what happens. We'll start off with 4x plus 3 is less than negative 2, and the other side, 4x plus 3 is greater than positive 2. Start by subtracting 3 from both sides, just like before. Now 4x is less than negative 5. Over here, 4x is greater than negative 1. Divide both sides by 4. We have x is less than negative 5/4. Over here, we have x is greater than negative 1/4. Graphing this on the number line looks like this. X is less than negative 5/4, open circle to the left. X is greater than negative 1/4, open circle to the right. We've seen this type of graph on the number line before, which makes it seem like this is a possible solution. However, going back to the original problem, we have the absolute value isolated and we have a less than sign, which indicates that this is going to be an and statement, not or, which would mean that x is both less than negative 5/4 and greater than negative 1/4. And clearly, it cannot be less than a number here on the left side and also greater than a number to the right side. So truly, the answer here is that there's no solution. Now, how do we recognize that from the very beginning? Well, just like before, we know that the lowest value that can come out of an absolute value is 0. So therefore, we're never going to get anything below that, which means we can never be less than a negative number. In fact, we can never be less than 0. So it's very important to recognize once you've isolated the absolute value, see if the other side has a negative and try to make sense of what's going on. If the absolute value of something over here is less than a negative number, you should realize that that's never going to be possible. No solution right away. In the prior example, the absolute value being greater than a negative number automatically meant that the solution would be all real numbers. Thanks for watching. If you found this video helpful, please smash that like button and subscribe for more videos.